Hello guys, again. I will discuss today more about the process of electron capture. Let me remind what we have studied before. We were studying about the types of rays that can emit a nucleus. A nucleus has different types of rays that they can emit. One of them is given by the process of beta decay. Usually when we have an initial nucleus with a set number of protons and n number of neutrons, and the total number of protons plus neutrons is A. When we have an excess number of neutrons, so the nature has something interesting, that is change the number of protons. One neutron changed to a proton, and one neutron minus 1, but we remain the same number of the neutrons and protons. So when this occurs, we require something extra, that is an electron plus antineutrino of electron. Let me remind that nowadays we don't know really if the neutrino should be equal to the antineutrino. So we don't know really that at the moment, if the neutrino is equal to their antiparticle. This is called Majorana, if they are Majorana particle. Okay, at the moment we don't know when the particles is equal to antiparticles. Okay, but this is just a question mark. So this process is called beta decay, beta minus decay. That I can explain again, is when you have, for example, one nucleus which has, for example, 2 neutrons with 1 proton. The nature somehow prefer change the number of protons. Change the number, yes, it's okay. Change the neutron by a proton, and we have 2 protons and 1 neutron. But when this happens, this is the beta decay. When this happens, we must to include, there is an emission of an electron plus antineutrino. Okay, this is the process of beta decay, that is the radiation that emit, that is an electron that they are emitting. So the problem that now I want to try to understand and explain, if it's possible, well, is the concept of electron capture. When we have one nucleus, let me erase this and write again the nucleus. Okay, here we'll have one nucleus. Okay, and inside the nucleus, this nucleus absorb an electron or capture an electron. But inside the same nucleus, capture an electron. The nucleus has a transformation that is the remaining nucleus, or the nucleus which we will obtain is the follow, has one one proton will change to neutron. And you have this. And we preserve the same number of protons and neutrons. But now we will have an emission of neutrinos. Okay, this process is called sorry, it's not, it's electron capture. The process of this is electron capture. Where, okay, let me write, this is electron capture. Okay, these people wrote only easy. Let me write exactly that people use. Okay, that is just easy decay. Okay, easy decay, electron capture decay. Okay. Here, let me explain more with more pictures what is going on. Let's plot or sketch a picture of the atomic spectra. Let's consider here the energy is x-axis. This is the energy, and when we plot only, for example, we have one state of a nucleus which has For example, let's consider a nucleus which has okay, with this notation, okay, let's consider this. Okay, a nucleus which has set number of protons, and this is the ground state of the initial nucleus. Ground state means that is the basic state, that is not excited state of the initial nucleus. I mean, for example, let's consider an atom which is not excited, which has in the natural form. Okay, here I can continue using the same notation. For example, okay, with pictures, let me continue doing the picture, and later I will explain more. Okay, we have this, and let's have here, this is another level of energy that correspond to another nucleus which has less mass of energy, that also is in the ground state. And when you have, for example, just this is a sketch. Here let me write okay, we have here 2 protons. Okay, this is just a sketch, a cartoon of something that could happen. Okay, we have a nucleus which has, for example, 2 protons and 1 neutron, and this nucleus will have only one proton, but now 2 neutrons. Okay, in the from one initial state, this is initial, and this is final. Okay, initial, final. Okay, so from here to here, we have this process, but this this final nucleus, in order to have this process, something should here emit, that is a neutrino of electron. But just like a comment, when we have this process, usually they don't go suddenly to the ground state, goes to one excited state. Okay, let me there is this more. I want to, okay, this is the purpose that we want to get. From one state goes to another state, but in practically the nature is not like we think as all. It's a quite different. The reality is that okay, let me raise more. Okay, what I sketched before is just when we start from one ground state to another ground state from different nucleus and emit a neutrino, and this is exactly that we have here, the electron capture decay. But okay, this sketch corresponds to the equation that we have here. Okay, but in general, it's not given by this, is given by this. Actually it's the same, but there is a quite difference. That's E is excited state. Okay, this star that I wrote here, okay, let me emphasize. Here we have a star. This star, this is okay, this is the basic state or ground state. I call basic, but this ground state. Ground state or basic state to me, and in my notation, is just the state which is not excited. But this is the excited that we can represent like K level. So first we go to one excited level, and therefore they okay, in this process from here to here, okay, here to here, okay, here should emit the neutrino, and the energy which we require to capture an electron is the energy that we measure here. Okay, let me write with another color. Here we have a difference of energy. Okay, here we have one difference of energy, and here we have another energy that is okay, the energy of the neutrino is involved in this area. Okay. I will finish soon. Just let me finish the explanation, which is not quite easy to explain. I can summarize what we were doing. Okay, let's start again. We have one initial nucleus. Let me write here one initial for one, and therefore this nucleus will capture one electron from itself. When this happens, they will get excited and suddenly they will change of the structure, because when this happens, when one nucleus capture an electron, the proton will change to a neutron. Okay, let me use colors to be more clear in the explanation. Okay, inside a nucleus, inside a nucleus the nucleus will change one proton to a neutron plus one neutrino. Okay, but in order to do that, one electron will be captured in the same nucleus. Here, these two parts, this is the part, for example, if we have here this nucleus, for example, here we have two protons and one neutron, and around him there are some electrons. Okay, there are electrons. Okay, this is the atomic case. So the nucleus will take one electron, and when it takes one neutron, one proton we will change to one neutron, and therefore we will have two neutrons. But when we have, for example, in order to take the electron, there are energy which we require. I mean, let me explain this part. Here we have one proton. I will explain again. Okay, we have here two protons and one neutron. Okay, and here we have electronic cloud that has the atom. Okay, so in order to take one electron, here, in order to take one electron, we require energy. Is the energy that we require to take the electron. This electron, we can say that is the energy of the electron capture. So, when we take this energy of the electron capture, is the energy of the electron capture, we will have, for example, in the other nucleus, we will have a hole in the other nucleus. Okay? Let me finish with this. I will summarize again. many times I will summarize. But this is important to explain. Okay, so here we have a whole, everything here together, everything, this is a nucleus, everything that includes, okay, this is an atom. This atom is excited. Here I can write, this is the y z plus, okay, it's not plus, it's minus. Okay, oh my gosh, I erased many things. Ah. Okay, I commit a mistake here. Okay, never mind. This is an excited state, okay, with star. It's an atomic excited because, okay, but this excited state should go to the not excited state. So, okay, they must to reorder somehow the distribution of electrons in the most get a distribution with the lowest energy, and therefore in this process we will emit energy. Here we emit energy